Assalamu alaikum students and welcome to another lecture of Slate. This is Khawaja Yasin and let's study chemistry. So, in O-levels chemistry, we know about many chapters. There are 13 chapters as per the syllabus, but for me and what I always say that the most important chapter is that of acids, bases and salts. Now, this seems like a very easy chapter. If we just talk about the acids, the bases, the salts, and the reactions that they undergo. But this chapter contains so many informations. For instance, the reactions of acids, the reactions of bases, and obviously their types as well. But most importantly, when we talk about salts, there are so many things that we need to look into. The types of salts, the preparation of salts. These are very important topics, students, because it's not that you're going to get questions regarding these ones. It's just that the questions that you're going to get from different chapters will have the equations from these reactions or the concepts of solubility of salts, which is very important. And the concept of the fact that if a salt is aqueous or not. And that we will be studying in the further lectures. And also about the pH and the indicators. So this is a vast chapter which covers so many topics and it is a part of so many subjects, so many other questions, and especially your P4. Your P4 mostly contains questions from these concepts and that of moles. So let's start this chapter. At first, let's start with acids. Now, there are various definitions of acids, but like for instance, initially acids were just famous for having a sour taste. We can easily remember the examples. For example, we know that we have citric acid found in citrus fruits. We have tartaric acid found in grapes. And most importantly, one of the most important one, acetic acid, also known as vinegar that you consume. As you can see, these things have sour taste. Even when we talk about another one, lactic acid, it is found in milk, and yogurt. But when we say that the milk has turned sour, that becomes yogurt. So even this has the tendency of becoming sour. I know this doesn't make, it has no relationship to chemistry, but it is easy for you to recall that. And a very important acid, HCl, which is found in our digestive system. So that is what we know about acids, that acids have sour taste. There are other properties which we will be talking about. But most importantly, when you have to define an acid, acids are is the species, is the entity. A species which donates H plus ion in water. Now, you need to understand that these two things are very important. Hydrogen ions and aqueous medium, which is water. An acid is not an acid without water, without it being aqueous, without it being dissolved in water. It will not play that important part. It will not be giving the hydrogen ions. So if it's not giving hydrogen ions, it's not playing its part of being an acid. The properties of acid are dependent when it is in aqueous medium. So acid donates hydrogen ions in water. Let's talk about hydrogen ion. We know hydrogen ion with another name as well. So we know that this is hydrogen atom. There is one electron. But in order to make it a hydrogen ion, this is H, and if I have to make it H plus, what will we do? We are going to lose that electron. This very electron will be lost. And we know about hydrogen initially, that hydrogen has one proton, hence one electron, but no neutron. Hydrogen has no neutron. So just look at this, students. If we have this hydrogen nucleus left, the electron has been taken out. It has been removed. So what is the configuration of this particular hydrogen ion? It has one proton. It has now 0 electrons and it has now 0 neutrons. So hydrogen ion. So students, when we talk about hydrogen ions are also called protons. Not the protons that you talk about, but since a hydrogen ion will only have a proton left with it, so we can call it a proton as well. So that is why we call acid is a proton donor. So we can call acid a proton donor as well. This is the most important thing that you need to understand regarding an acid, that acid donates proton or a hydrogen ion in water. That's something you need to understand and know that. Now, when we talk about laboratory, because acids are very much used in labs. Initially, we talked about the acids found in real life. But in lab, the most important acids are hydrochloric acid, which is HCl, sulfuric acid, which is H2SO4, and nitric acid. These three are very important acids which we will be discussing further, because you need to memorize that these are important ones. Why? Which we will be talking about that later. Now, as we've talked about, acid donates proton in water. Now on that very basis, let's discuss the types of acids. So students, types of acids. Acids have various types, but they're classified in different ways. For instance, classification on the basis of hydrogen ions, that an acid donates. So we are going to classify acid on the basis of the hydrogen ions that it donates in water. So whenever you put an acid in water, for instance, let's look towards HCl, which is hydrochloric acid. It is going to give hydrogen ion. So if HCl is giving us a hydrogen ion, remember, HCl is a covalent compound. Hydrogen is a non-metal, chlorine is a non-metal. But in water, it forms ions. An acid forms ions in water. Or I can say acid ionizes or dissociates into ions in water. So that's what you need to know about acid. So whenever you put acid in water, HCl has given me H plus. But it's not just H plus. We also get Cl minus. So that's what we get here. Now, likewise, if we use H2SO4, what do we get? This is a common mistake from the students in the very start, but not at the end, by the end, because now they know. I'm going to dissociate H2SO4, but will I do it this way? H2, which is the hydrogen gas. the reactions which give out hydrogen gas are very rare. And let me tell you, this is not one of those reactions. And I'm going to erase it now. Most importantly, we talked about acid that it gives out hydrogen ions. This will give us again hydrogen ions, not the H2, which is a gas. So 2H plus, because it's giving out 2 hydrogen ions. Not lastly, HNO3, it's H plus and nitrate ion minus. Again, it's the same thing. Phosphoric acid, 3H plus and phosphate ion, which is PO4 minus 3. We have done it in the crisscross methods in the video of moles, that how do we form the formulas. In the moles, we have also studied about polyatomic or complex ions like sulfate, nitrate, hydroxide. We'll be studying hydroxide in this chapter again. Nitrite, sulfite, various important ions that you need to memorize. You should look into that video for that, the video for moles. Now, we can see it easily. This is a very basic classification. Now, this is acetic acid, ethanoic acid. That name you will study in organic chemistry. So technically in HCl, what do we see? 1 hydrogen, so 1 hydrogen. 2 hydrogens, so 2. 1, so 1. 3, so 3. But when we talk about organic acids, this is an organic acid. Organic acids have carbon in them. So whenever you try to dissociate organic acid, only this hydrogen will be dissociated. Only this hydrogen will leave. So we're going to get this and this. We will not touch these hydrogens, students. So remember, these hydrogens are not available for ionization process. So on this classification, what do we call these? This is just giving 1 proton. So monoprotic, diprotic. This is also monoprotic. This is triprotic. And lastly, since though it has 4 hydrogens, but acetic acid, ethanoic acid is only giving out 1 hydrogen. So this too is monoprotic. Now, one good thing about this classification, they're not going to ask you to classify acids. They're not going to ask you to do that. Normally, the terms monoprotic, diprotic, they are mentioned in the exam. And they mostly explain it to you that this particular acid is a monoprotic acid because it gives out 1 hydrogen ion. But it's better to be acquainted to these terms. So that is why we've studied this. Now let's talk about the other type. Classification on the basis of strength. Now students, this is a very, very, very important classification. On the basis of strength, there are only 2 types of acids. As you can see, strong acid, weak acid. Which is a strong acid? Now these are very commonly asked definitions in the exam along with the examples. So strong acid, the one which completely is the important term, ionizes in water. So this strong acid, it completely ionizes in water. And weak acid, the one which partially ionizes in water. So we talked about, okay, I say that the only purpose of an acid's life is just giving out hydrogen ions, nothing else. Acid gives out hydrogen ions. So an acid which gives out more hydrogen ions is a strong acid. Let's look at these examples. Apparently, what do we see? We see that since phosphoric acid is giving 3 hydrogen ions, it should be the strongest. Then it should be the sulfuric acid. And obviously, this should be a weak acid, this should be a weak acid. But let's analyze the situation. So the point is, students, a strong acid is the one which completely ionizes or dissociates in water. For example, if I put HCl, we just saw what happens. It's H plus Cl minus. That's how it dissociates. It has been dissociated. Now, this is something that you cannot observe right there. This is something you cannot observe in the exam. Okay, since it's HCl has one hydrogen, it must be a weak or a strong acid. Phosphoric acid has 3 hydrogens, so it must be a, a stronger acid. But that's not the case. This is something that you need to memorize. I repeat, this is something that you need to memorize. Rectify the concept, it's going to help you out. So, HCl is a strong acid. Sulfuric acid is a strong acid. Even nitric acid, that's why I said these are important types, is a strong acid. Let's talk about phosphoric acid. It's a weak acid. Just like HCl, ethanoic acid or acetic acid was also monoprotic. But HCl is a strong acid and methanoic acid is a weak acid. So this is a property, it's a qualitative property. So you need to memorize that. And one very important thing that which I'm going to tell you now, that all organic acids are weak acids. All organic acids are weak acids. That you need to memorize. Okay? So all organic acids are weak acids. Just like H2SO4, we have H2CO3, the carbonic acid, the fizzy drinks. So if I dissociate carbonic acid in water, what do we get? We get 2H plus CO3 carbonate ions. But let's see this. HCl, sulfuric acid, nitric acid, they are strong acids. Memorize that. Acetic acid, phosphoric acid, carbonic acid, they are weak acids. So, students, this is something that you'll have to memorize. This is the property. You cannot make HCl a weak acid anyway. If HCl is a strong acid, it will remain a strong acid. If ethanoic acid and organic acid is a weak acid, it will remain a weak acid. You cannot make it a stronger acid. So this is the property that you need to memorize. So definition is very important, which completely ionizes in water, which partially ionizes in water. For instance, they don't ask you about it, but let's say, if I'm taking 10 HCls, so it completely ionizes. So what do I mean by that? I will get 10 hydrogens and 10 chlorides. But let's say, if I'm taking 10 phosphoric acids, just example, so it will partially ionize, like not all of them will ionize. So let's suppose even that's a huge number. Out of 10, only 1 will ionize. The other will not ionize. So if out of 10, 9 stay as it is. So this will be 1 into 3, just 3 hydrogens. So what am I getting? Nothing. HCl is giving me 10. Yes, but H2SO4 also completely ionizes. So 10 H2SO4s, which is moles of H2SO4, will give me 20 hydrogen ions. So H2SO4, which is sulfuric acid, is stronger than HCl because it gives more hydrogen ions. But these are not, because they partially ionize in water. And the last classification, concentration. So what is concentration? Now at this point we will just talk about acids, because in the moles video you can see that the concentration is the amount of solute in 1 decimeter cube of solution. But in acid, we'll just not call it solute, we'll call it acid. Amount of acid in 1 decimeter cube of water or solution, just to understand. So this is concentration. So concentration has two types. The first type of concentration is concentrated acid, and the other one is dilute acid. So concentrated acid has more acid added into 1 dm cube of water, and a dilute acid has lesser acid added in 1 dm cube of water. So more solute or acid in 1 dm cube of water, and dilute vice versa. Now, for instance, how do we express it in concentration? Let's talk about, we have 2.0 moles of ethanoic acid, and we have, or for dilute we can say 0.0001 mole per dm cube. My apologies. Now look at this. I have diluted HCl quite a lot. I can use HCl this way as well. There is no harm in doing that. So you see the numbers. The numbers tell you a lot. Let's make it 3. So if you see a good number of concentration, that's a concentrated acid. If it's in a point form, such a small number, concentrations can be like this. 2.37 into 10 raised to power negative 4 mole per dm cube of whatever. So that's a dilute acid. So dilute acid is only because you add more water and less solute. That's it. It's not a quality, it's a quantity based model. So if they ask you in the exam, differentiate between strength and concentration of acid, so for strength, we know strength. What is strength? We talked about either it completely ionizes or partially ionizes. So strength is the degree of ionization of acid, and concentration is the amount that we talked about here. The amount of solute in 1 dm cube of water. That's concentration. But the important point is, here, can you just see I have diluted HCl quite a lot, and ethanoic acid is very concentrated. But does that make ethanoic acid a strong acid? Not at all. It will still be a weak acid. And does this concentration, this low concentration, make HCl a weak acid? HCl will still be a strong acid, because that's what I said. Memorize that. So, strength cannot be changed. Concentration, easy. Add more solute, it gets concentrated. Add more water, it gets dilute. So can be changed by adding solute or water. So these are the 3 types when we talk about the classification of acids. Now the most important part of this chapter are the reactions of acids. What do we know about acids? Let's talk about the properties of acids. A, sour taste, as I said already. B, they're hazardous, which means they are corrosive. They can damage your skin or eye. They are irritants. They are corrosive. Can damage, and that we know about acids. Acids can damage skin. pH, it's a concept that we'll study later, but they have a pH less than 7. In the topic of pH, we'll study that how lower the pH, stronger the acid. That's what we know about acid. Then we'll also study about indicators. So turns blue litmus paper red. That's also acid. It turns, you dip a litmus paper in the acidic solution, the color changes. A blue one turns red. So these are some basic properties, but the important one are the reactions. Just 3 reactions about acids, but these are very important. They will be repeated in so many chapters. The first one, acid plus metal. You get salt plus hydrogen gas. So students, when I write an equation in the word form, a generic word form, it means this will happen, whatever you do, whatever you say. These will be the results. For instance, HCl plus sodium metal. It's a very common example. So salt will be NaCl. It's a displacement reaction. And we get hydrogen gas. And hydrogen gas is H2. So we need to balance the equation. Here we have 1 hydrogen, here we have 2 hydrogens. So 2. So this is 2. Now this is also 2. But now we have 2 Cl here, but just 1 Cl here. So we multiply it by 2. So chlorine or chloride are also balanced. But now 2 sodiums and 1 sodium, so 2 sodiums. So this is the equation. Let's talk about another example. H2SO4 plus calcium. What do we get? H2. Now, in this case, we'll get H2, not H plus. Plus CaSO4. Let's do a different example because students make that mistake quite often. H2SO4 plus sodium. What do we get? It's a very common mistake that I'm going to do. Don't make that mistake. Students write it as NaSO4 plus H2. So let's talk about sodium sulfate. How should it look like? We know that sodium ion is Na plus, sulfate ion is SO4 minus 2. So we do the crisscross method, that this number will come here and this is Na plus 1, so this will come here. So this becomes Na2SO4, not NaSO4. That would be a wrong one. Your balancing of equation will go wrong. And after that, even the whole moles concept will go wrong if you make the wrong formula. So formula making is very important using the crisscross method. So this would be Na2SO4. Now let's balance the equation. 2 sodium, 2, 2, it's balanced. So acid plus metal, remember it's a very important equation. Acid plus metal is salt plus hydrogen gas. There are only 3 reactions of acids. So not a long thing to understand. Now let's talk about the other one. Acid plus metal carbonate will give us 3 things now. Salt, carbon dioxide, and water. So remember, in the above reaction, hydrogen gas is of key importance. As I told you, not many reactions give a hydrogen gas. So we know about hydrogen gas. That hydrogen gas pops a burning splint with a pop, extinguishes a burning splint with a pop sound. So that is the identity of the gas released when acid reacts with metal. So I can write it here. Burning splint with a pop sound. So that's hydrogen gas. Now, in this reaction, which one is the important one? Carbon dioxide. And what do we know about carbon dioxide? Turns lime water milky. Now, what is lime water? It is calcium hydroxide. So that's lime water. Let's do any metal carbonate, any reaction. So for instance, H2SO4 plus calcium carbonate, which is limestone, which is marble. It's very important. You need to understand that. You can understand solubility rules, how it is insoluble. That's in our next video in the mole chapter of moles. So, what is going to happen? We get water, that's a compulsion. We get carbon dioxide, again, that's a compulsion. What are we left with? Just sulfate and calcium. So, calcium sulfate, it's a very basic one. So, in these reactions, take out the product which is the eminent one, which is definitely going to be there, which is carbon dioxide and water. And then you make the salt. Let's do another one. HCl plus magnesium carbonate. What do we get? Again, the same one. Carbon dioxide plus water plus MgCl2. Because magnesium is +2, chloride is -1. Crisscross, and this becomes MgCl2. Now we need to balance the equation. It's balanced. Because there are 2 chlorides, so making it 2, the hydrogen also become 2. It's a balanced equation. So remember, acid with metal is hydrogen gas. Acid with metal carbonate, it's carbon dioxide, water and salt. But carbon dioxide is the important one. Last equation, acid plus base, or there are other terms used for that, alkali, metal oxide, metal hydroxide. You can get various terms in the exam. They can call it metal oxide, they can call it base alkali, they can call it metal hydroxide, but the reaction will be the same if it's with the acid. What would that be? Salt plus water. So later on in the next video, we are going to study about bases or alkalis. So we would understand that how bases also have an effect, which is not a good one, and acids also have an effect. But when we add the two together, we get a neutral salt and a neutral water. So it neutralizes the effect of both. If you react an acid with a base, the effect of acid and base is neutralized. It's ended. So we also call this reaction a neutralization reaction. So let's quickly do that. HCl is an acid. Sodium hydroxide is a metal hydroxide. What do we get? NaCl, the same salt, and H2O, it's a balanced equation. Let's do it in a different way. H2SO4 plus calcium oxide. Because metal oxide can also be there, as I said. The reaction will be the same. It would be calcium sulfate, calcium and sulfate, and oxygen plus H2, water. So this is a neutralization reaction. This is a very important reaction, and I would say this is the most important reaction. When we study the solubility rules, when we study the preparation of salts, this one is done in a different way, which is titration method, and this one, metal carbonate one, is done with an excess method. So you need to understand the equations as well. Likewise, this one, because that depends on the states. So students, that's all for today in this video. So we have 3 reactions for acids: acid with metals, acid with metal carbonates, and acid with an alkali or a base. And in the last one, you only get salt and water, and that's called a neutralization reaction. In the next video, we are going to talk about bases, indicators, and pH. So thank you so much for being here with me. Allah Hafiz.